angles and how to name them. It's more vocabulary, in my opinion. And it's, to me, it reminds me of order of operations. You know how you do parentheses and you multiply, divide, and so forth? Well, we had to come up with some of the same conventions for angles, and so that's really what we're talking about today. That first note says, have I given y'all one? I've already given this to y'all?
Yes.
Okay. Good, remember? An angle on the coordinate plane is in standard form when the vertex is on the origin and one ray lies on the positive x-axis. Okay? And so the ray on the x-axis is called the initial side. And I'll underline that. Blue initial side, and so this is what we're looking at right here. There's our initial side on the positive x-axis. And then the other ray is called the terminal side. Which that kind of makes sense. You got your initial side and your terminal side. There's that there. And counterclockwise rotations result in positive angle measures. So what happens is you start on the positive x-axis, okay? And if you go counterclockwise, which is this way, you're getting positive. If you go clockwise, you get negative angle measures. And so if you start on the positive x-axis and you go clockwise, which will be this direction, you're going to get those negative angle measures. We just had to set something up, okay? And so I don't know why counterclockwise is positive and clockwise is negative, but that's the convention, so we can all kind of be in agreement. And if you were to go all the way around, you're looking at 360 degrees, which I think we did that. One full revolution, 360 degrees. So not a whole lot real surprising there, but that's some good vocabulary. Now, reference angles, or actually drawing angles. We're going to sketch an angle. Start off, we're going to sketch a 75-degree angle. So remember, we start on the positive x-axis, so we're starting, let's just say right there, okay? And we need to rotate counterclockwise 75 degrees. So in my head, I know if I go all the way to here, how many degrees would that be? 90. So I don't want to go quite there, right? So I'm going to kind of eyeball it. I'll start right here. I'm going to stop right there. Okay? That's in standard position, 75 degrees. Okay? Now look at the next one. It's negative 160. So still starting on the positive x-axis. Okay, so I'm just going to put a little right here. Start right here. Since it's negative, I'm going to go clockwise, the way a clock moves. So I got to kind of think about this. Okay, so here I'm moving. I've moved 90. I need more. What if I go all the way to here? How many degrees would that be? 180. That's too many. So, okay, I'm going to do 90. I'm going to go. I'm going to stop right there. So that's what a negative 160-degree angle would look like. And so, you know, let's go back to number one. If this is your initial side, what quadrant is your terminal side in on number one? What quadrant is your terminal side in on number one? What quadrant is your terminal side in on number two? 3. Now let's look at number 3. We're going to start here on the positive x-axis. And it's positive, so we're going counterclockwise. Okay, I can go all the way around. That gets me to 360. do I want to go all the way over to this 90? That'd be too many. So I need to, I'm going to go 360. I need to pick up, what is it, 70 more degrees. So I'm going to go to about right there and stop. So that's drawing angles. The takeaway, start on the positive x-axis, counterclockwise positive, clockwise negative. Radians versus degrees, and we talked about that. We talked about how you can look at something in feet, and then you can look at it in inches, and we know how to convert. So this will be a little bit of a review, but a radian is based on the arc length. If you'll remember, we took the little pipe cleaners and measured the arc length around. We figured out, what happened there. And so 360 degrees is equivalent to pi radians. And so if 360 is, 2 pi radians, 360 is 2 pi radians, so 180 is just pi radians, which is what we actually used for our conversion. And here's your little note for how to go from radians to degrees and degrees to radians. Let's look at number 4 together. It says convert each measure to radians. So we're going to take that 30 degrees, and it says multiply it by pi radians over 180. And something I didn't think about your Inspires being able to do, but that they can, instead of trying to simplify right here, you can do 30 over 180. And if you'll put it in your calculator, it'll reduce it for you. So it looks like Ryan's already kind of on it. Will you do 30 divided by 180? See what you get.
I don't know.
What is it? So it's the calculator gave you 1/6 back. And so in trig, we're not going to do 1 times pi, so you just do pi over 6. And that saves you from having to reduce in part of the process. Now, when you go to college, you don't have the Inspires. It will be able to do that. But. Okay. Number 5 will be 150 degrees multiplied by pi over 180 degrees. I got 5 pi over 6 for that. By the time I did my reductions. For negative 220 degrees, get negative 11 pi over 9. And now we know what that negative means. It means that we're moving clockwise. Convert each measure to degrees. So if you want to go from radians to degrees, we're going to do 180 over pi. And that gives me 4 times 180 is 720 over 3, which is 240. I'm going through this conversion fairly quickly because we spent a whole period where we just practiced, actually 2 days before spring break. I'm going to give you the answer to number 8 so that when you work it on your own, you can check your work, and the answer to number 9. Go ahead and make a note of the answer, and I'll let you check it out. Okay, coterminal angles. Angles in standard position that have the same terminal side are called coterminal. they're going to give us an angle, and they're going to want to give us, they're going to want us to give them back coterminal angles, a positive one and a negative one. So let me show you what I mean by that. Let's do 65 degrees. So I'm going to sketch out 65 degrees. XY. So I start on the positive x-axis. I know 65 degrees is going to be about right here. So there's my 65 degrees. Now, there could be another angle that ends up at that same place that is not 65 degrees. How could that happen? How could something end up in that very same place and not be 65 degrees? Absolutely, it's a circle. Maybe and I'll do this one in blue, maybe we start, or let's do green. Let's say we started right here, and we went all the way around, and then decided to go around part of the way again. We're still at 65 degrees, right? Okay, so what number would that be? Well, to find out, all I'd have to do is 65 plus 360, which is 425 degrees. So there's one positive coterminal angle. Now, is there another option for how I could have ended up at that place? Yeah, I could have went around twice, right? But what if I had went around the other way? Yeah, what if we had went clockwise? Still started at the positive x-axis, but instead of going counterclockwise, we went clockwise. What degree is that? It's negative something, but what is it? How much negative is it? What? Negative 295, and the easy way to find it is just do the 65 degrees minus 360, and it gives you negative 295. So most of the time, all you're going to do, I turn the heat shift comes on all the way over, so I don't know, must be getting kind of warm outside. Add 360, take away 360, and most of the time that's all you have to do to find your coterminal angles. So I'll leave 540 to you, so you have one to practice on. But for 12, let's look at one with radians. Okay? So, if we do 13 pi over 18, that's 130 degrees. So, let's see, it's going to be about, now, for the radians, you're going to do 13 pi over 18. Now, we added 360 when we were dealing with degrees. What are we going to add here? Talking about radians. So how are we going to deal with the radians? If we want to show that we've worked ourselves all the way around instead of 360 degrees, how many radians is that? 2 pi radians. So you're going to have to add 13 pi over 18 to 2 pi. Alright, now we got a few little fraction issues, right? Because we don't have the same denominator. So how do you change 2 pi to have a denominator of 18? They're both going to have a denominator of 18, right? So I make them both have a denominator of 18. And so that makes the numerator be 36 pi? Or 30, yeah. Isn't 36 over 18 the same thing as 2? So what I did is I said 1 times 18, 2 pi times 18 to get the correct fraction. And then when I added those together, I get 49 pi over 18. That's 1. Now I'm going to do the same thing, but subtract. And I'm going to work over here, even though this is not this problem. I'm going to take 13 pi over 18 and subtract 2 pi. But again, I've got to change it so they both have a denominator of 18. So that'd be 36 pi over 18 is the same as 2 pi. And that gives me negative 23 pi over 18. So you're either adding 360, subtracting 360, adding 2 pi, subtracting 2 pi. And I will leave 13 for you to do on your own to see if you've got it. So 11 and 13 I'm going to need you to do on your own. Reference angles. The reference angle is the positive acute angle formed by the terminal side and the x-axis. So let's sketch it and find it. Reference angle is the acute. You know, acute's what? It's a cute little angle less than 90 formed by the terminal side and the x-axis. So let's do 225 and see where we end up at. We want to start here on the positive x-axis, 90, 180, and if I'm at 180, how much further do I have to go to get to 225? Just a little bit. How much a little bit? How much difference is there between 225 and 180?
Like
45. Good, 45. So I'm going to go another 45 degrees. And I'm going to indicate that right here. So I want another 45 degrees. Okay. So what is my reference angle? Remember your reference angle, here's my terminal side, right? And here's the x-axis. So what's my reference angle? 45 degrees, good. Your reference angle is the angle between your terminal side and your x-axis. So in this case, it's 45 degrees. Now let's do another one. Negative 310. Start here on my positive x-axis, but this time I'm moving clockwise because of that negative sign. 90, 180, 270, and I've got to go another 40 degrees to get to the 310. Is everybody okay with me ending up there? Okay, so my reference angle is between your terminal side, which is this, and your x-axis. So here's my reference angle. What is the measure of my reference angle?
That was more than 30.
50. Because I had to go from here to here's 40. So I had to go to get to 9. All these are 90, so it's 50. Good. Okay, let's do. I'm going to go ahead and do 16 with you. It's positive. So I start on the positive x-axis and go counterclockwise. Okay, now you're going to have to think about this. Remember how your pi's work. The whole thing's 2 pi to go all the way around. This is half a pi. This is a whole pi. This is a pi and a half. And that's 2 pi. And I'm going to start here and go 2/3 of a pi. So this is half a pi. Do y'all want to go all the way here? No. That'd be too far. So I'm going to go all the way to here, which would be about 2/3 pi. But now that's not my reference angle. My reference angle is between the terminal side and the x-axis, which is right here. What's the measure of that? I went over 2/3 of a pi. What's the measure from here to here? If from here to here is 2/3 of a pi and all the way over is a whole pi, how much does that leave here for this one? 1/3 of a make sure that you can tell where your terminal sides end up at, what quadrant. For instance, on 14, we ended up in the third quadrant. In 15, we ended up in the first quadrant, and in 16, we ended up in the second. So, please finish those ones that I said that I was going to leave for you to do.